Good morning. Today we will be working on square root functions. This is part 2. So there's a lot of information in part 1 if you need to go back and review that. We're going to again talk about the parent function attributes, which is just review. We're going to work on transformations again with some domain and range. What we're going to add today is writing the equation given the transformation. So we're going to start off first with the parent function again. This is what the parent function looks like. This is the graph that we're going to be translating. So we're going to talk about domain, range, and just the 3 different ways to write it. I prefer interval notation, so I typically will use that most of the time, but we should be aware of all 3 kinds of notation. So domain, for interval notation, my domain is going to be 0 to infinity. For square root functions, every time you have a number, it's going to have a bracket. That bracket means it can be that number. And parentheses means that it is going to approach that but never get to it. You can never actually get to infinity. So the way to write that as an equality is we say that x is greater than or equal to 0. And set builder looks just like an equality. We read that x such that x is greater than or equal to 0. That means 0 to infinity, guys. Anything greater, if it's greater than 0 forever, that means it's going up to infinity. My range are actually the exact same numbers. My range is my y value. So for interval notation, domain and range are not different in how they look. But your inequality has to have a y for range, which means your set builder also has to have a y for range. The way this reads again is y such that y is greater than or equal to 0. Okay, so we're going to be doing transformations, and our transformations will shift my domain and range. It'll shift my x and my y value. So this is a summary of what we reviewed. We have a, b, h, and k. A is going to be outside your square root. A causes a stretch or compression, and it can cause reflections as well. It would reflect over the x-axis. B causes a horizontal stretch or horizontal compression, and we always take the reciprocal of it. And B has to be underneath your radical in front of your x. H has to be under your radical. Now, because you see a minus sign there, we're always going to change the sign of what we see. And so it's going to shift the graph left and right. K cannot be under your radical. So K will be after your radical, and K is going to shift the graph up and down. So let's start this with a couple practice questions. In this first problem, we have 2 things happening. We have a 5, and we see a positive 2. But because this is my h value underneath the radical, this means that h is really negative 2. So what do these numbers do? Well, a is 5, which causes a vertical stretch of 5. H, we always change the sign, so h is really a negative 2, which makes our graph go left 2. So remember that our parent function started at 0, 0, but this h means the graph shifted to the left 2. Now, A causing a vertical stretch is not going to change my domain and range. Now, guys, my points are not an exact ones. The only one that I really care about is my starting point. Okay. What's my domain? Well, we look at our x values. My domain, my lowest x value is negative 2, and it's going to go on to infinity. So negative 2 to infinity. When we have numbers, numbers are always brackets. Infinities are always parentheses. Range is my lowest y value. So my lowest y value is 0. Well, how high up was it going to go? It's going to go up forever. So my range is 0 to infinity. Okay. The second question, I have 2 things happening with it. I have a 2/3 for A, and I have a negative 1 after the radical, which means this is my k value. So my A is 2/3, which causes a vertical compression. My K is negative 1, which makes my graph go down 1. So the graph that normally started on 0, 0 is now going to go down 1. This is my starting point now. Now, vertical compression just means that the graph got a little bit more compressed, which instead of going up as high, it'll be a slower increase. So my domain My domain is 0 to infinity. Remember, for domain, we're looking at our x values. That's my lowest x value to my highest x value. My range, the lowest value is -1. And since it's going up forever, it's going to infinity. Now go ahead and try number 3 on your own. Go ahead and check your work. So what happened here was that -3. Now remember, this 3 caused a vertical stretch. A lot of students make the wrong, select the wrong choice here and think it's a compression because we say less than 1. But guys, remember, we look at the absolute value. The 3 tells me it's a stretch. The negative made it flip upside down. Okay? This -2 meant that h was really a +2, and the graph went to the right 2. So the graph that started here normally moved to the right 2. It flipped upside down and it got taller quicker. So my domain is 2 to infinity, my lowest to my highest. My range, how low is this graph going to go? It's going to go down to -infinity. Where does my y value stop? The y value stops at 0. Okay? Try number 4 on your own. So this one had multiple transformations, okay? It didn't just do one thing. The graph moved to the left 1. Remember that we changed the sign here? So the graph moved from 0, 0, left 1, and down 2. So my domain, my lowest x is -1, and it goes to infinity. My lowest y is -2, and it goes to infinity. Infinities have parentheses. The numbers are going to have square roots. Also, it was a vertical compression, which means the graph didn't grow quickly. The graph is going to grow very, very slowly, but it is growing. Okay, 2 more practice ones. Number 5. So we have 2 things happening to number 5. We have a number under the radical in front of the x. That number is my b value. So my b value is 3. Now, b is a little bit tricky. So b causes horizontal. Well, is it a stretch or compression? If the number is greater than 1, it's a compression by the reciprocal. What's the reciprocal of 3? It's a horizontal compression by 1/3. Personally, I like to take the reciprocal first and then remember if it's a compression or stretch, because then it follows the same rules as a vertical. After I flip it, if it was less than 1, it's a compression, and if it was greater than 1, it's a stretch. My h is the opposite of what I see, so it's not really a +4. It's a -4, so the graph went left 4. So the graph that normally starts on 0, 0 went to the left 4. A horizontal compression of 1/3 means that it's going to grow rapidly. Remember, horizontal compression looks like a vertical stretch. So it's going to grow quickly. What's my domain? Well, my domain is -4 to infinity. My range is 0 to infinity. Now go ahead, pause the video. Try number 6 on your own. All we had on this one right here was the k value of -3, so the graph shifted down 3, but the graph still looks the same. Okay, my domain, my lowest x is 0 to infinity. My lowest y is -3 to infinity because it is going up forever. 2 more practice questions and we'll move on to writing. So this first one here, we have a couple things going on. We have a 2 and a -4. So a 2 is a vertical stretch of 2, and the 4 means that h is a +4 and it moves to the right 4. So what does this do to the graph? Well, the graph went to the right 4. And a caused it to stretch, which just makes it grow quicker. My domain, my lowest x is 4 to infinity. My lowest y value is 0, and the highest is infinity. Go ahead and pause number 8 and try this one on your own. This one had an h and a k, left 1, down 3. left 1, down 3. It looks the same as the parent function. My domain is -1 to infinity. My range is my y. My range is -3. And it's going to go up forever, so we put infinity. So now we're going to practice just a few questions of writing equations if we are given the transformation. Let the graph of f be a translation of the square root parent function. To the left 4 units and up 3 units. Write the equation of f. F is just, the function is f of x. Okay, so what do we know so far? We know that the graph went left 4 units and the graph went up 3 units. What letters do they signify? Well, left and right means that h is a -4. And up 3 units means that k is a +3. There's nothing else happening, so there's not a third thing here. We just have the blanks just in case. So what's my equation? Well, f of x equals, okay, the square root, because that's the parent function, is the square root of x. Now, when you plug in the h value, we're going to change the sign. So h is going to be +4. And the k has to be outside the square root. So there is your equation. Now, my domain. Remember that the h affects my domain. So the graph went to the left 4. So my domain went to the left 4. Now, and be honest, if your b value was negative, we would have to really pay attention to the order of the domain, but we're not going to do that to you right now. So we're not including any reflections when we write the equations. Just for today, we won't include reflections. My range, well, the graph went up 3. So my range starts at 3 to infinity. Now, if that confused you, where did those numbers come from? You can graph it. Remember that this is the parent function. Okay. Now, the graph went to the left 4, and it went up 3. So here is the graph. My lowest x value was -4, and it was going to the right forever. My lowest y value was -3, and it was going to go up forever. A lot of lines there, but I want us to just pay attention to the transformation. Okay, remember that the h that shifts it left and right is going to affect domain. The range, the k value that goes up and down, is going to affect the range. Let's try it again. We have, let the graph of f be a vertical stretch of the square root factor. Oh, it split it. Vertical stretch by a factor of 2. That means that a is 2. Followed by a translation to the left 4 units. That means that h is -4. And up 3 units. That means that k is 3. So my equation is f of x. That's when it says write the equation of x. It should be write the function. F of x equals 2 square root of x plus 4, because we always change the h sign, plus 3. So this graph, it actually looks almost the same as the one we just did. But what changed was that the graph is going to grow quicker. But guys, that a value doesn't change my domain. What changed my domain was the h value by going to the left 4. What changed my range was going up 3. Okay. This is the last one we're going to do. Go ahead and pause the video and try to do this last one on your own. Okay. Check your work. What we had here was 6 units to the right. That means h is a +6. But guys, when I write the equation, the h always changes signs. And k being a -5 means the graph went down 5. So to the right 6 and down 5. That's what the graph looks like. You don't need the graph for this problem, But I did it in case you wanted to see it. So remember that the h going to the right 6 is your domain, 6 to infinity. The range going from -5 is going to go up forever, so it's -5 to infinity. Thank you for watching this video. If it helped you at all with transformations and doing domain and range of the transformations, then go ahead and give it a thumbs up. And if you want to subscribe to this channel, I will be posting more educational videos. Thanks and have a great day.